Welcome to Career Guidance Max playlist. In this video, I'm going to start next section continuity. So from this section, you will get 1 8 mark from university question paper. So before going to start the problem, just we can understand what is continuity. Continuity or continuous. A function f is continuous at a point a. If we can say limit x tends to a, f of x equal to f of a. That means the functional value and limit of this f of x both are equal. Okay, this is called a continuity. When x approaches to a, you may get one function value. That function value is equivalent to that limit. Okay, so here we can say a function f is continuous at a point a. Here you will have two values. One is right hand side limit and another one is left hand side limit. So left hand side we can write limit x tends to a minus f of x equal to f of a. Limit x tends to a plus right hand side limit f of x equal to f of a. When this left hand side and right hand side are both are equal, your function is continuous, we can say like that. Okay, or otherwise how to identify your function is continuous or continuity. Just see this first one, f is well defined. Is nothing but f is well defined means in your function, you, for example, you will have x square. Okay, I'll take here x equal to 1. When I'm taking x equal to 1, I will get the function value 1. So that means the function f is well defined. And limit x tends to a, f of x exists. Already you know that how to identify exists. If you want to know how to check exist or not, just refer the previous videos. We solved many problems in this section. Limit exists. So left hand side and right hand side are equal means exist, otherwise doesn't exist. We cannot conclude it is a continuity. So when it is not satisfied any one of these, if it is not satisfied first one itself, the function is not continuity, it is discontinuity, we can say. So for sometimes the function f is well defined, satisfied, but it is not satisfied exist, so it's not a continuous. For example, at a subinterval x less than 2 and x greater than 2, that means at a particular subinterval point, this point must be a discontinuous. Okay, whenever you will have the subintervals, subfunctions at a particular separated limit, it gives discontinuous. Okay, so based on this, we'll solve some problems. The first one, for what value of the constant c is the function f continuous on the interval minus infinity to plus infinity. Here they said the function is continuous. Which point gives continuous function? That is, we need to identify here. Here we are not going to prove whether it is a continuous or discontinuous. Just we are finding which value gives the continuous function. Okay, the function is f of x equal to cx square plus 2x, x less than 2. And second one is x cube minus ex, x greater than or equal to 2. It is a continuous function. Don't worry about these strictly less than or greater than or equal to. Both are same only. Okay, we start with the 2 itself. The given function f of x is continuous in the interval of minus infinity to plus infinity. Thus minus infinity to plus infinity, we can separate the real line. We can take minus infinity to plus infinity. Within that, this is, for example, you can take 2. X less than 2 means this side of 2 to minus infinity. The left hand side, your function is c square plus 2x. Right hand side is your function is x greater than or equal to 2. Start with 2 and ending with the infinity. Your function is x cube minus cx. Okay, already they told the f is continuous. So continuous means we have to prove left hand side and right hand side. Okay, so first I am going to prove left hand side. I'll start with the limit x tends to 2, left hand side minus f of x. So I'll write limit x tends to 2. The left hand side, your function is c x square plus 2x. Okay, here you can substitute 2 equal x equal to 2, 2 square you will get 4, 4c plus x equal to 2 plus 4. Okay, which is equation number 1. And similarly you can find right hand side limit. Limit x tends to 2 only, right hand side plus f of x equal to limit x tends to 2, right hand side function is x cube minus cx. Okay, here you can substitute x equal to 2, I will get 2 cube is 8 and minus c into x equal to 2, 2c. Okay, this is equation 2. So now based on from equation 1 and 2, based on equation 1 and 2, already they told the function f is continuous. The f is continuous means both left hand side and right hand side must be equal. So f is continuous at a point, f is continuous at a point a. The formula is limit x tends to a minus f of x, left hand side is equal to limit x tends to a plus right hand side f of x. Both should be equal if it is continuous means. So based on from equation 1 and 2, I will say limit x tends to 2 left hand side is equal to limit x tends to 2 plus means right hand side. The values are left hand side 4c plus 4, right hand side 8 minus 2c. Minus 2c shift to left hand side, 4 you can shift to right hand side, you will get 4c plus 2c equal to 8 plus 4 shift to right hand side minus 4. Okay, 4c plus 2c 6c and 8 minus 4 4. So c equal to 4 by 6 and you will get c equal to 2 by 3. At a point 2 by 3 your function is continuous. Okay, a very simple problem, but this one is a repeated one. Problem 2. Find the values of a and b that make f continuous on minus infinity to plus infinity. Already I told when in a subinterval at a point must be a discontinuous, maybe a discontinuous point, but they said the whole thing is continuous based on the point a and b. Find the values of a and b that make f continuous on minus infinity to plus infinity. That those 2 points are representing the function is continuous at a particular function. Okay, so I'll write a real line minus infinity to plus infinity. Here our points are starts with 2. This is 2 and this is 3. For example, we can take here x less than 2, that means here 2 to infinity. So the function is x square minus 8 divided by x minus 2. Here 2 to 3, 2 less than or equal to x, less than or equal to 3 means your function ax square minus bx plus 3. And x greater than or equal to 3, that means we take 3 to infinity. Okay, so this is our function 2x minus a plus b, right? So if it is f is continuous means already you know that at a particular point, based on that we have to find the left hand side, right hand side value and we have to equate, you will get one term, right? In similar manner here also, based on previous problem 1, based on that I am going to solve. So first I will take a point at x equal to 2. At x equal to 2 I will take. At x equal to 2 means first I am write limit x tends to 2, left hand side minus represent function f of x. Left hand side of 2 means this is. The function is x square minus 8 divided by x minus 2. So I'll substitute limit x tends to 2. The function is x square minus 8 divided by x minus 2. Here you can substitute x equal to 2. 2 square means 4 minus 8 divided by 4 minus 8 divided by, here x equal to 2 means you will get 0. That means minus 4 divided by 0 is undefined form. We cannot able to write like this. So by L'Hopital rule, here we can differentiate both numerator and denominator. X square differentiation 2x, constant 8 differentiation 0, x differentiation 1, constant differentiation 0. We will write limit x tends to 2. Okay. Now I am going to substitute x equal to 2. I will get 2 into 2, 4. So this is equation 1. At a point x equal to 2, I will find right hand side value. Limit x tends to 2 plus f of x equal to, at a point 2, right hand side your function is what? Ax square minus bx plus 3 is your function. So just write it that. Limit x tends to 2, right hand side function is ax square minus bx plus 3. Here you can substitute x equal to 2. You will get x square, 2 square na 4a minus 2b plus 3, which is equation number 2. The question itself they told f is continuous, right? The question itself they told f is continuous. Continuous means both left hand side right hand side are equal. I'll write from equation based on 1 and 2. Based on 1 and 2, I'll write here limit x tends to 2 bar left hand side represent limit x tends to 2 plus right hand side represent. Left hand side is 4, right hand side is 4a minus 2b plus 3. Simplify this, you will get 4a minus 2b and 4 minus 3 you will get 1, which is equation number 3. Right? Now in similar manner I am going to find another point. Here you will have one more point is 3. Here our limit starting with 2 ending with 3, right? For example, at a point x equal to 3, I will take limit x tends to 3 left hand side function is equal to 3 left hand side function is ax square minus bx plus 3. Here you can substitute x equal to 3. I will get 9a minus 3b plus 3. Okay, which is equation number 4. And similarly you can find right hand side limit. X tends to 3 plus represent right hand side. F of x equal to limit x tends to 3. The right hand side of your limit is 2x minus a plus b. 2x minus a plus b. Here you can substitute x equal to 3. We will get 6 minus a plus b, which is equation number 5. Again I already told the given f is continuous. The function f is continuous means both left hand side right hand side are equal. So we may write limit x tends to 3 minus left hand side function equal to limit of x tends to 3 plus right hand side term. From equation 4 and 5, I'll write left hand side is 9a minus 3b plus 3 equal to, right hand side is 6 minus a plus b. Okay, so simplify this. 9a minus 3b, this minus a shift to left hand side, plus a plus b minus b, 6 plus 3 shift to right hand side, minus 3. So we'll get 10a minus 4b equal to 3, which is equation number 6. So based on these 2 points, we'll get equation 5 and 6. So from equation 5 and 6, so equation 5 is 4a minus 2b equal to 1. This is equation 5. And equation 6 is 10a minus 4b equal to 3. This is equation 6. When solving these two equations, we'll get a and b value. Okay, the very simple one. Here you will have two variable and two system of equation. Any one you can eliminate, you will get rest of one. Substitute that one in any n from this equation, you will get another one values. Okay, so from 5, I'm going to multiply with the 2. So I'll get 8a minus 4b equal to 2. 6 as it is you can take 10a minus 4b equal to 3. Here I am going to eliminate b term. So 5 and 6 I am going to subtract, then only we can eliminate. Sign will change, minus will change plus, plus will change minus. Minus and plus cancel off. 8a minus 10a minus 2a. Here 2 minus 3 minus 1. So you will get a equal to 1 by 2. Okay, this a equal to 1 by 2 from equation 5, substitute a equal to 1 by 2. So 4 into a equal to 1 by 2 minus 2b equal to 1. So you'll get 2. 4 by 2 is 2 minus 2b equal to 1. So therefore minus 2b equal to 1 minus 2. So minus 2b equal to minus 1. So that b equal to 1 by 2. So therefore the solutions are, the continuous point is a equal to 1 by 2 and b equal to 1 by 2. Okay. Next, problem number 3. So find the domain where the function f is continuous. When a function is continuous, you can find the domain. This is one question. And one more term, also find the number at which the function f is discontinuous. Based on the point, we can able to find whether it is a discontinuous or continuous. Here we have subinterval 0 and 0 to 2 and x greater than or equal to 2. Okay, the function this one. First I will write the real line minus infinity to plus infinity. While doing problem in differential calculus, first you can understand the question. Okay, identify the limits, identify the functions left hand side, right hand side, then you can start to solve the problem. Very simple one. Here I'll start with the 0. 0. X less than or equal to 0 means minus infinity to 0, your function is 1 plus x square. And 0 to 2, here your function is 2 minus x. And 2 to infinity, your function is x minus 2 whole square. Okay, so now I am going to solve this. First I will take at x equal to 0. In similar process, you can apply left hand side limit. Limit x tends to 0, left hand side function f of x. 0 left hand side function is 1 plus x square. So I will write here limit x tends to 0. The function f of x is 1 plus x square. Okay, here we can substitute x equal to 0. So you'll get 1 plus 0, this is 1, which is equation number 1. Okay, and then next, limit x tends to 0 plus, that means right hand side f of x. The limit 0 right hand side function is 2 minus x. I'll write here limit x tends to 0, 2 minus x. Here substitute x equal to 0, 2 minus 0. So the answer is 2. From equation 1 and 2. See equation 1 and 2. Equation 1 and equation 2 both are not equal. So left hand side, right hand side are not equal. The function f is discontinuous at a point x equal to 0. Already I told you, whenever you have the subintervals at a particular subinterval, it is a discontinuous point. Now we proved it is a discontinuous. Okay, now I'll take second point. In our problem, the second point is 0 and the second one is 2, right? So at x equal to 2, I will write limit x tends to 2 left hand side function. See your left hand side function at particular 2 left hand side is 2 minus x. So I'll write limit x tends to 2, left hand side function is 2 minus x. Here you can substitute x equal to 2, 2 minus 2, you will get 0, which is equation number 3. Okay, next, right hand side limit you can find. Limit x tends to 2 plus right hand side term f of x equal to limit x tends to 2, right hand side function is x minus 2 whole square. So I will substitute here x minus 2 whole square function right hand side at point 2. Here you can substitute 2 minus 2 whole square, you will get 0. So this is equation number 4. Now equation 4 and based on equation 4 and 3 and 4. See equation 3 and equation 4 both are equal. Left hand side and right hand side both are equal. So f is continuous at x equal to 2. If it is continuous means we can able to find domain. So domain at a particular continuous point. Here in your problem there is no denominator term and there is no square root. Simply you can understand your continuous, your domain is minus infinity to plus infinity, right? But here you will have subinterval 0 and greater than or equal to 2. That means we can say here minus infinity to 0 union 0 to infinity based on your problem. We return domain. Okay, so this is the procedure to identify continuous or discontinuous and finding a values. So from this continuous section you will get 8 mark for identify A or identify B. Check whether it is a continuous or not. You should remember always one thing, when you have a separated subinterval limits, separated limits means discontinuous limits means at a particular point the function should be a discontinuous point. So for example, when you are drawing graph, it goes like this. At a particular point here you will have discontinuous. This is discontinuous point at a particular point. In similar manner you will have two subinterval. You start with here greater than 2. Here I will start with greater than or equal to 2 means, or strictly greater than. So here strictly less than. That means you will get at a particular point, this must be a discontinuous point. Okay, thank you.